Hi guys, my challenge for today is to make this cheapest THC system on the market work with my Mach3 CNC plasma cutting table. This is a SF-HC25G system from China. I bought it on AliExpress and it cost me only $130 including shipping. It has a display unit, the main THC unit, the voltage divider board. It also includes this cable to connect from this unit to the display unit. And this manual. My first THC system was a THC-3T02 from Robot 3T, a Vietnamese company. I had trouble using that system to cut thin sheet metals, but actually I think the problem was coming from my machine. At that time, I was still having this fake TB6600 installed on my Z-axis, and that might be the reason that my Z-axis was running crazy. After that, I sold my THC-3T02 on eBay, and I made this type of shield for my torch, and I called it a mechanical THC. This shield will float on the surface of the sheet metal and keep the tip of the torch at a constant distance from the workpiece. It had been working very well for me. I haven't gotten into a situation that the shield got stuck on the sheet metal yet. But because this shield keeps scratching on the surface, the workpiece will have to be clamped down tightly, otherwise it will move around with the torch. Even though it is the cheapest solution, it is not the most convenient and most elegant one. That's why I decided to try again with another THC system. This time I chose this one because it is the cheapest one that I can find. The reason I call installing it a challenge because everything about this THC system is in Chinese, which is not the language I am best at. I do know about 5 Chinese characters, but I think to read this manual that came with the system, it will need about 5,000. You can also download the English manual on the internet, but I don't think that will help you much since they just do the auto translation. It seems that Google's Chinese only a bit better than mine. In addition, this system wasn't actually designed for Mach3. From what I saw in all the videos about it, these THC were made for the crossbow CNC plasma cutters, which use their own controlling platform. With that being said, I don't think that it is impossible since this system works as a standalone THC. If I understand correctly, once installed, the whole Z-axis here will be controlled by this system, not Mach3. Mach3 will only take care of the aux start signal, then the X and Y axis after receiving the aux OK signal. One thing also special about this setup is that it doesn't use a stepper motor to control the Z-axis. It will use a brush gear motor such as this one by outputting a 24-volt voltage. I have a 8mm lead screw on my Z-axis, so I got this 37mm gear motor that has the maximum speed at 300 RPM. So the maximum linear speed of the Z-axis will be 2400 mm per minute, which is in the range with all the torch lifters on the market. First of all, I will have to make an adapter to install this motor on the Z-axis. I will cut it from a sheet metal that is 1/8 of an inch thick using this CNC plasma cutting table itself. The cut is not very clean because I am still learning. I will need to clean it up using my sander and my drill press. After sanding it, I used 1/8 of an inch drill bit to make the holes to size. Now I will use 6 of the 6mm length M3 bolts to fix this motor on the bracket. That's it. Now I will uninstall the stepper motor on the Z-axis. I will still reuse the wires to power the geared motor, so I'm just going to cut the wires right here. Then I will take this piece of 2040 aluminum extrusion bar that I have spare from building my other CNC machine. I will use 2 of the M5 bolt 25mm lengths to go through the back of the Z-axis block and fix this bar on here. I will just put the bolt through here. Put the T-nut at the back. Install the bar on and tighten the bolt. I have a little hiccup here. The shaft of this motor is 6mm. My coupler here is only from 5mm to 8mm, so I will have to make this hole bigger. I will use my 6mm drill bit and bore it out. Now it fits perfectly. Next step, I will use some short M5 bolt to slide through this bracket. The bolts that I have are a bit too long, so I use some washer to space it up. Slide it through the slot. Put the T-nuts on. Now I just slide the coupler onto the lead screw and tighten the set screws. Now I will only need to tighten the bolt. For the wires, I have 4 wires right here, so I will use 2 for each side. I will solder the wire to the connectors. And that's it. Next step, I will try to control this motor using this unit. Here's my stepper motor driver for the Z-axis. I will uninstall it. Now I will have enough space to install this unit about here. I will have to connect the wire for the motor here, motor plus and motor minus. It doesn't really matter which way you connect it. If the direction is reversed, you can change the wire position later. To power this unit, I will have to use 24 volt. The geared motor will use up to 3 amp, so I will need a power supply that is more than that. I will use this power supply that I have. Now I have the power supply connected to this unit. I just turn on the power supply. I have 24 volt here, 24 volt over here, and also over here. But here I have nothing. So I think that I will have to input 24 volt as a reference in here from the controller board. Next step, I will have to try to move the Z-axis up and down using these 2 signals. I'm not sure how it works, but what I will try first is just I will connect a wire to 24 volt minus or ground, and then the other end of the wire I will try to touch the down and up signal to see if the Z-axis move. If it doesn't, I will connect the wire to 24 volt plus and touch the pin here, and the same thing just to see if it move up and down. I'm using both my phone and my camera. I will try to sync the video as best as I can. I will touch the down first. Up. Down again. As you can see that the Z-axis is actually moving up and down correctly already. So I don't need to swap the wire here. One thing I just found out about the 24 volt plus and 24 volt minus here, it's actually not 24 volt plus. It depends on the output voltage of the output from the controller board. If your controller board output is 5 volts, you should connect 5 volts here, not 24 volts. On my NVEM board, the output level is 12 volts, so I input 12 volts in here. Next step is to make the controlling of the Z-axis more convenient. I can think of different solutions. The first one is to use two of the limit switches like this. One pin connect to the 24 volts minus, the other end to down and up pin. Then you will have two mechanical buttons to move the Z-axis up and down. But that is not very elegant and convenient, so I will try to find a way to control the Z-axis through Mach3. After a day of research, I finally was able to write this macro and made it work with Mach3. Let me explain quickly what is in here and how you can add it to Mach3 macro library. First, you will have to include a virtual keyboard map. Then you choose a key to move the Z-axis up, another key to move Z-axis down. For me, I choose the U key to move the Z-axis up and the D key to move the Z-axis down. And here are the corresponding code for the U key and the D key. If you want to choose another key, you can look at this website here. Then you should be able to find the code for whatever keys that you want to use. Here, the macro check if the key to move the Z-axis up is pressed. If yes, the output number 3 will be activated. If not, the output number 3 will be inactive. And the same thing with the move Z-axis down key. The signal to move the Z-axis down will be on the output number 4. Now just make sure that you save the macro into this name, macropumps.m1s. Copy this macro into Mach3 folder, macros, plasma, paste it here, open Mach3, go to config, general config, and enable macropump right here, run macropump, click OK. Go to config, ports and pins, go to output signals, enable output number 3, output number 4. You can choose different output if you wanted. Just make sure that you also change it in the macro. Choose the corresponding port and pin. On my board, it will be active low. And click apply. And that's it. You are ready to control the Z-axis through Mach3. Let me show you the connection between the controller board and the THC unit, and I will show you how it works on the machine. I just take a wire, connect it into the output number 3. Another wire input the output number 4. Now at the THC unit, just connect the output number 3 to the up pin, output number 4 to the down pin. And that's it. Now let's see how it works. Now I will try to move the Z-axis up by pressing the U button. Move it down with the D button. As you can see that it works perfectly. The only thing about this is that Mach3 doesn't know the Z-axis position. This number will stay the same even if you press up and down. But that is expected, so let's move on to the next step. Now I will try to install the limit switches here. The 0 pin will be the limit switch just on the floating Z-axis. This is the upper limit switch. This one will be the lower limit switch. And the other pin of the limit switches will be installed to the 24 volts minus. I already have a limit switch for the floating Z-axis. This one will be connected to the 0 pin. Now I will have to install the upper limit switch and the lower limit switch. I take two extra limit switch. One I will install it like this. And the other one down here, just like this. I will take two long wire. Each one is to connect to the normally open pin on one of the limit switch. And the common pin, I will solder them to this wire, which is the common wire on this switch. That way I will have less wire to run. I think that I will use some of the mounting tape. Next step, I will run the wires to the THC unit. This one is the common pin. I connect it here. This one is from the limit switch on the floating head. I will connect it to 0. The color code here is a bit confusing, but I have this red one is for the upper limit switch and this one is for the lower limit switch. So I put this one to limit plus. This black one to limit minus. Next step, I will try to see if the limit switches work. To be safe, I will click the limit switches manually. Then I will try to move the z-axis up and down to see if it actually moves. Now it doesn't move. When I release it, it moves. When I click it, it doesn't move. Let me try the lower limit switch. Can move down. Click. It doesn't move. So the limit switches work correctly. I don't think that I can test the 0 limit switch. That one is for the THC to find the surface of the sheet metal when it actually cutting a G code. But I think that those 2 limit switches work correctly. This one should work also. Now I will finish connecting this unit to the controller board. There are 3 pins left. This pin is the output signal from the controller board to start the AUX. This one is our OK signal, just output from this unit to the controller board. After receiving the OK signal, the controller board will output a auto tracing signal that will tell this unit that the OK signal will receive. And so this THC unit will start tracing the height of the torch. The only problem with this auto tracing signal is that Mach3, once receive the OK signal, it doesn't output a response signal. So I will have to set it up manually. To do that, I will modify the macropump script. Let me just show you quickly on the computer. In here, I just opened the macropump script that I installed earlier. I will input the OK signal into the input number 1. So I will write if is active, input 1, then I will send the auto tracing signal to the output number 2. Else, deactivate signal output 2. And if okay, in a simple way this should work, but I want to do some extra condition is that when the controller board receives the OK signal, I don't want those keys to be active. So what I will do is that I will move this in here. I will do like this. Else, check this. This is almost good, but I want to do something extra that I want to avoid the case that these 2 keys are activated at the same time. I will move this block here into this else. Now let's revise this. First of all, the controller board will check the input number 1. If it is active, it will output the signal from the output number 2. If the input number 1 is not active, the output number 2 will be inactivated. And then in this condition, it will check if this key move Z up is pressed. If it is, it will activate the output number 3 and then put out the message move Z up. If this key is not pressed, it will deactivate the output number 3. Then it will check if the move Z axis down key is pressed. If it is, it will activate output number 4. If it doesn't, it will deactivate the output number 4. And that's it. I think this should work better. So now you won't be able to move the Z axis up and down when the machine is running a G code. Maybe the THC unit already have this function, but I just want to make sure. Now I will have to enable the input number 1 and the output number 2 in Mach3. I go to config, ports and pins, input. I will have to enable the input number 1, port number 1, pin. For the pin, I will have to put pin number 3. The pin number 1 is reserved for the e-stop button. The pin number 2 is reserved for the probe. Then output signals. Here I will enable the output number 2. Here I show you port number 1 before, but it is actually should be port number 2 on my controller board. So I put port number 2. For the pin number, I will put pin number 2. And that's it. I think that this macro should work. I cannot really test the OK signal, so I will just test the move z-axis up and down for now. I will try actually move the z-axis all the way up until it hits the limit switch, and then all the way down until it hits the other limit switch. The moment the upper limit switch clicked and the z-axis stopped, now I will try to move it down. Actually, I will have to remove this plate to move it all the way down. It also stops when the lower limit switch is hit. And I can move it up. So I think that the new macro worked. Now I will connect the wire from the controller board to the THC unit. Over here to start the AUX, I use the output number 1 connected to this relay. So now I will disconnect this. And I can remove this relay. Now I will connect this wire into the output number 1. I will need a wire for the output number 2. And one more wire for the input pin number 3. On this board, the printing here a bit shifted, so I had to count the pins here just to make sure that I connect it into the right pin. I actually come up with a way to test the input number 3 and the output number 2 by using this limit switch. I will connect this limit switch to the input number 3 and 12 volt. And then I will manually trigger the input and see if the output change. And now I have the output and 12 volt is 0. I will close the limit switch. It jumped to minus 12 volt. Unclick. Click. So the macro actually worked correctly to detect the state of the input and then enable and disable the output. Now the off start signal I input in here. The auto tracing signal from the output number 2, I will input it in here. And this wire from the input number 3 on the controller board, I will connect it to the 0 OK pin. And that's it, I'm done connecting this unit to the controller board. Next step, I will install the aux voltage divider board. Here the aux voltage divider board, it have a connector here that is connected to this relay to trigger the plasma aux. I think that the relay here will be powered by the 220 volt input from here. It have this connector with the 2 pin is to input the aux voltage. It has this 4 pin connector is to be connected to the THC mainframe unit. I want to install this board on the side of the plasma cutter. So I made this piece of plywood that I will drill 4 holes here, and I will use some stand-up screw to fix this board on this plate, and then I will glue this plate on the side of the plasma cutter. Now I will open my plasma cutter to run some wire from inside to this board. For the next step, you don't really need to open the plasma cutter. You can take the arc voltage from here, the ground clamp and the hose connector. And for the 220 volts, you can take it directly from your outlet. But for me, I don't want to have the open wire dangling around, so I just got to connect the wire from inside the plasma cutter. Here is the other end of the ground clamp. I will loosen these nuts and attach this red wire here. I will strip it long enough. And I will make a loop around here. I will cut the extra wire, just make sure that it doesn't touch anything else. Now I can tighten the nuts back in. I will slide this wire through this vent slot. I will do the same on the other side with the hose connector. Now for the 220 volt, I will take them from here, this one and this one. That's what I got from following the wire from the on and off switch. I will try to solder this end of the wire to this connector. And that's it. Now I can close the plasma cutter. For now, I will glue this board on the side of the plasma cutter right here. In the future, if the THC system works well, I will drill some holes here on the side and install this board directly on the cover of the plasma cutter. These two wires are the 220 volt wire. It doesn't really matter which way you connect it in here. Now to the arc voltage wire, you have to distinguish the color. The red one I connected to the ground clamp. It would be on the plus sign. The wire from the hose connector would be the black wire. It goes to the minus side. This one, you just push the wire in here. And that's it. Now I will connect the trigger wire here. This one, it also doesn't matter which way you connect it. Next step, I will take a cable with 4 connectors and connect from this board to the THC unit. I will use the red one for the 24 volt plus, black one for the 24 volt minus. Our start ST will be the blue one, and the out voltage output V will be the yellow one. Last step, I just connect the corresponding wire into here. And that's it. I'm done connecting this THC system to my CNC plasma cutting table. Next step is to test. if this system can actually control the torch high. Before cutting anything, I just want to see the sequence of the THC work correctly. Once the THC system receives the all-start signal, the torch should go down, touch the plate, and go up to the initial high. I don't really know what the initial high right now, so I just have to run a test without the plasma cutter on. In Mach3, I just click on torch on. It seems that the sequence was correct, but the torch didn't lift up high enough. The nozzle of the torch is still touching the plate, so I will have to see how to adjust it to make it lift a bit higher. After taking a good long look at the manual, I tried really hard to understand what they say, so finally I think I figured it out. On this side here is the set arc voltage. On this side will be the actual arc voltage. This one to adjust this number. This one is to adjust the arc OK delay. If we turn it up, the THC will take some time before sending the arc OK signal. That will increase the pulsing delay. I think that you should turn this all the way down. You only turn it up in case you find out that the pulsing delay that you set in sheet cam is not long enough. You can add a little bit more. This one is to adjust the initial position. If you turn it up, the torch will lift up a little bit higher after it touches the surface. I think that I will have to turn it up a lot. Maybe like this to test. Let's see how it works. Okay, let's try again. As you can see that the knob worked, but this time it lifted up a bit too high, so I will have to turn it down a lot. A little bit better, but I want the distance is about 3 mm. I think like this will be good. Let's move on to the next step. Next step is to see what number I should set here. Right now I just put a random number. I wanted to know what range I should set it. I don't want the torch to be too far away from the surface or crashing into it, so I will have to know roughly a range for the arc voltage. What I will do is that I will try to turn on the arc manually and read this number. Hopefully without the all-start signal going through the THC, the number still show up here. To start the arc manually, I connect this limit switch between the ST pin and the 24 volt minus here. When I click this relay should close. Yes, it does. I don't know if you can hear it. Now, for example, if I want to cut at 20 amps, I will set 20 amp here and 60 psi for the air pressure. I will turn on the torch and read the number on the display. Okay, so here we go. Let's see. It worked. Even the number was jumping really fast. But I think that it was about 108 or 110. I think that this number will change if I change the ampage. So let me just try that. The cutting ampage now is 35 amp instead of 20. So this number decreased if the ampage increased. It was about 98 or something like that. So I think that you will have to write out your own chart for each cutting ampage. I will readjust it at 20 amp. Again, it was about 108 or something. 108 is the arc voltage when it cut empty. That means that the sheet metal is really far away from the torch. To make the torch go closer to the sheet metal, I will have to decrease this number. I will put it about 102 for now, just to see how it works. I can refine this number later. And I will keep this limit switch here for the future when I need to read the arc voltage again. One more thing that you will need to do in Mach3, just go to config, ports and pins, go to input and go down to THC on, enable it. It will be the same port and pin at the input number 1. So I put 1, 3, I tip low, apply, okay. Before running a G-code, make sure that you press this button, THC. Once doing this, every time the all-start signal activated, Mach3 will wait for the OK signal to come back before continuing running the G-code and also the macropump script. We'll wait for the same signal to generate the auto tracing signal to input back into the THC, and that's it. Now let's switch to sheet cam. In here, just make sure that you choose the right post processor. Go to option, machine, post processor. Choose this one, Mach3 plasma no Z, because Mach3 actually doesn't control the Z axis. And that's it, click OK. Here I already create a tool for my plasma cutter. I will cut a 20M 60 psi on a 1.5mm sheet. So I estimate the curve is about 2mm. The feed rate, I'm not sure which one is the best. I just put 2500mm per minute for now. The pulse delay, I put 0.5 seconds. It's just a test, but I think this will be enough. Here from pulse high to cut high, you don't need to worry about it. The THC system will take care of those parameters. Now I will import a drawing. I will start by cutting a few small circles just to see if I set the voltage correctly. The diameter of this circle is 3 centimeters, so it's quite small. So just click on a new operation. Choose the tool here. Outside offset or inside offset or no offset, it doesn't really matter. It's just a test. Layer 0. I put the arc here about 5mm. And I check reverse cut direction. And that's it. I click OK. Nothing really special, so I just export the G code. Now I'm going to try to run the G code for the circle. Somehow after the arc start, the G code doesn't run. Let me see what is the problem. I think there's some problem with the arc OK signal. Mach3 doesn't seem to receive it. So let me see what is the problem. After 2 hour debugging, I think I found the problem. I'm a bit confused, but I think that I can make it work. When I connect this ground wire into this ground here, it is the ground from the power supply. The voltage from here to here is still 12 volt, but the THC cannot output the signal here. And when I connect this wire here, just any other output that I don't use, so the voltage here is still 12 volt, and the THC can output this signal. But when I enter this signal into here, it doesn't change the state of the input number 1. So what I will do is that I will disconnect this wire. And I will go through a relay here. It go into here. I will input the 12 volt into channel 1. On this side, I will need 12 volt to power this relay. I will take it from here. Now on this side of the relay, I will take the normally open pin and the common pin. The common pin, I will put it with this wire. It is the ground of 0 volt. The normally open pin, I will put it into the input pin number 3. And that's it. I think this should work. And don't be intimidated by all these connections. I will try to put together my own version of manual so you can follow step by step to install this THC system. Now let's see how it works. Now let's try again. It seems to be running, but the torch is too far away from the sheet metal and it doesn't cut through. Let me just set the arc voltage a bit lower to see how it cuts. As you can see here, after install the relay, I was able to do a lot of test cut, all the circle around here. Some will cut nicely, some wouldn't. And after a lot of adjustment, I think that I found the problem. Actually, it might be two. Let me just show you the first and more prominent problem. I think that the lead on my lead screw is too high and 8mm is too coarse. So every time the motor just move a little bit, the Z-axis will move a lot in the linear direction, and it doesn't matter how much I adjust the sensitivity of the THC system. The torch or crash into the workpiece or we're too far away from the surface. So I think that I'm going to have to change the lead screw on my Z-axis. I have this one with 2mm lead per rotation. So I'm going to use this one instead. With this motor at 300 RPM maximum, the maximum speed will only be 600mm per minute. That is really slow. In the future, I think that I will change the gear motor too. Now I have the small lead screw installed. I will have to adjust the sensitivity of the THC system. Let me just show you how. On the display unit, you will see this hole here. Inside there is a screw that you can turn. If you turn it counterclockwise, it will increase the sensitivity. If you turn it clockwise, it will decrease it. Right now my Z-axis is extremely slow, so I turn it all the way down, all the way counterclockwise. And that's it. Now the system should be really sensitive. And what that means that the THC system will react to any type of change in the arc voltage. I think that this will work very well with the slow Z-axis and on the type of stock that the warping is not too steep. So the maximum speed of the Z-axis can still follow the slope of the warping. When you cut something that is really warpy, like the angle of the warp is really steep, you will have to increase the Z-axis speed. Maybe get a gear motor with the speed is around 600 RPM or 800 RPM. For now I will try with this. But before continuing to the cutting, let me just show you another trick. I think that will help to improve the precision of this system by 20%. On this arc voltage divider board, there's a trimmer here that you can adjust the arc voltage dividing ratio. Right now the ratio should be around 50/1, which means that the arc voltage coming from here will be divided by 50 times and then output to the THC unit. But for this type of cheap plasma cutter, the arc voltage is actually lower compared to the good one. So when you use high ratio, the arc voltage will be compressed and the variation will be very small and the THC system will be less accurate. So what I wanted to do is that I will decrease this ratio. The smallest ratio I can get is 40/1. So I just turn this trimmer counterclockwise all the way down. Actually, let me just show you the reading right now. Here the maximum arc voltage that I can set is 185. So as long as the reading on this side is smaller than that, I will be fine. So right now I set my plasma cutter at 20 amp. And the reading is about 108. If I turn this counterclockwise to decrease the ratio, the reading will be around 128 or 130. So the arc voltage variation will be bigger when the torch gets closer or further away from the workpiece. That way the THC system will react a lot faster to the variation. And also you will have more range to adjust here. Right now on this side it read about 130. I'm going to adjust this side to a lot lower. After doing a few cuts before, I think that I will have to increase the amperage to 25 amp to cut this 1.5mm sheet metal. And I will set this number about 95. This number here you can refine it later after doing a few test cuts. And as I told you before, you will have to write out your own chart for each cutting amperage. So now let's try to run a test cut. And also just to make sure that it will cut through, I decrease the feed rate to 2000 millimeter per minute. Okay, here we go. I forgot to turn on the THC in Mach3. Let me just try again. As you can see that it worked, but I think that I should make the torch cut a bit closer to the surface. So I set the arc voltage to 92. This time I don't know if you can see it, but the piece is really whoopy on this side. As you can see that it cut just fine. Now let me just make a piece that is really whoopy and see how the THC system performs. This is just to show off, but I don't think that it will cut anything this wavy in real life. Now as you can see that why we need faster Z-axis, because this part is too warpy and the Z-axis didn't move fast enough and the torch start a piece. Then the THC system detect the collision and it turn off the arc and tell Mach3 to stop the G code. So in overall it worked well, but to cut this piece I would have to replace the gear motor on the Z-axis. I will receive the new gear motor tomorrow and I will show you how it cut on this piece again. I got my new gear motor here, 800 RPM. Let me install it on the machine and see how it works. Now with the new gear motor installed, I will have to readjust the initial high for the torch and also the sensitivity of the THC system. Here we go, let's try. Somehow with the 800 RPM motor, it seems to be worse. The cut stop even earlier compared to the 300 RPM. I think that this motor has faster final speed, but the acceleration is really slow. And for the THC system, the acceleration is actually more important compared to the final speed. So let me just try with other motor. I also ordered another motor is 600 RPM. Let me just try with this one first. And if it doesn't work, I will try to think of other solution. This geared motor also doesn't work, so I think that the problem was coming from the lead of the lead screw being too small. I will recycle this one that I got from my 3018 CNC. It has 4mm lead. Let's see how it works. Now I have a fast Z-axis again. Let's see how it works. It seems to be working a little bit, but it's still not really fast. So what I will do is that I will change back to the 300 RPM gear tomorrow. So now the maximum speed on my Z-axis is 1200 millimeter per minute. Let's see again how it works. It seems to be working here. Let me just try again. After doing a few more tests, I observed something very interesting, that the torch was having a hard time to follow the slope upward, but it can follow the slope downward very nicely. After seeing that, I think the problem was not the THC system. It's really coming from the acceleration of the motor, and that really related to the torque of the motor. So I went back on Amazon and checked the spec of this type of motor, and the torque of this 300 RPM motor is only 0.3 kilogram centimeter. So the same type of motor with higher speed like 600 RPM or 800 RPM that I tried, the torque is extremely low. So to make the Z-axis react faster, I would have to change to another type of gear motor that have higher torque. Here's what I got from Amazon. It is double the price compared to that motor. It is also 24 volt, 470 RPM, but the torque is rated at 1.2 kilogram centimeter, so it is 4 times stronger compared to that motor. So it should work a lot better. But to match this motor on the machine, I would have to cut a new bracket, and of course I will use this machine itself. So let me just do that first. It seemed to cut okay. Only this part here, that the tip of the torch was touching the sheet metal, so the THC just turned off the torch. I would have to cut it out using my angle grinder. After that, I will mount the new motor and show you how it cut again. To mount this motor on the bracket, you will need few of the M4 bolt, probably about 10mm length will be fine. It seems that 10mm a bit too long, so I will use some M5 nuts to space it up. I should use 4 bolts, but I only have 3. I think this should be fine. And another problem that I have here is this coupler. Right now it is from 6 to 8. The shaft of this motor is 8mm. So I will have to use my drill to make the hole to 8mm. And that's it. Once again, I have a new gear motor installed. I just did a few tests moving the Z-axis up and down, and somehow with the new motor, the Z-axis seems to be moving up and down a lot slower compared to the old motor. Yeah, it takes forever to reach the plate. So let me check if I can make it move faster. I took another look at the THC unit, and right here next to the motor connector, there's two little switches here. I don't really know what they do, but they are right next to the motor, so they might have something to do with the motor speed. Let me just change the position of the first switch. Now let's see how the motor moves. I don't think that the second switch do much, because I didn't notice any difference in the Z-axis speed. It's not faster or slower, so I think that only the first switch can affect the speed of the motor. Now I have a fast Z-axis. Let's see how the system works. I will try to cut this really thin piece of sheet metal, 0.5 mm thick. What I will do is that I will cut a line along the length of this piece at the feed rate of 6,000 mm per minute. And for starting, I only make it a little bit curvy, and then I can increase the curve until the Z-axis cannot follow the slope anymore. After that, I will know the limit of my THC system. I only lift this end a little bit. Let's see if the THC can follow. The cutting amperage right now is 15 amp. The air pressure is 60 psi, and the set arc voltage is 108. At 15 amp, it doesn't cut through. Let me just increase the amperage a little bit. I'm cutting the second line at 25 amp. As you can see that this time it cuts through and the THC can follow the curve very nicely. Let me just lift this up a little bit. The THC can still follow the curve nicely. One thing that I noticed is that the Z-axis have a lot of small movement up and down. It looks kind of you're cutting wood with a handsaw. So I will try to reduce the sensitivity of the system on the display unit. I will only try to reduce it a little bit. The movement is still a bit jagged. Let me just reduce a bit more. It looks pretty smooth now, so I think I will keep it like this. Now it is show time. I made this piece is really curvy, also 0.5 mm thick. I don't think that you will cut anything this curvy in real life, but just to test this THC system, I went a bit extreme. I will cut at 6,000 mm per minute. The amperage is 25 amp, so hopefully the THC system can follow all these curves. Here we go. Well, how nice was that? The THC system performed perfectly on this whoopee sheet metal, and I have to remind you again, the feed rate was 6,000 mm per minute. Now I have to say that I am very happy with the performance of the THC system, but there is one more thing that I noticed with the cutting routine, is that at the end of the cut, the torch doesn't lift up high enough to the clearance high. It only touches down and move up to the initial high. Let me just show you one example. As you can see that there is actually two problems. The first problem, as I told you, that the torch doesn't lift high enough after cutting. The second problem that I noticed right here, that the torch doesn't turn off after cutting. So I will have to figure that out. Let me just show you how I will do it on the computer. Here's what I will try to do. I will go into Mach3 folder, macros, plasma, and I will create two new macros. Just copy this one 2 times, rename it 801 and 802. You can name the macros anything that starts with M and a number that is not already existed in here. I will open the M801, delete everything in here, and then I will write activate signal output 3. This is to lift the torch up. Save. M802. Delete everything. Deactivate signal. Output 4. Output 3. Save. Now I will open sheet cam. Here the first thing I wanted to do is to add some delay at the end of each cut. So I open the tool, pause at the end of cut, just add some delay here. I will leave it at 1 second as I said before. Click OK. Now I go to option, machine, post processor. Here the same post processor, Mach3 Plasma no Z, edit post. I will add a variable here. I will name it clearance delay. I put 2 seconds for now. I might need to change it later depending on how much the torch going to lift up within 2 seconds. Now I will go down and find on pan up. Here as you can see, end delay is the pause at the end of cut that you said earlier. Now I will add something else. I will copy this line and put M801. This will call the macro 801 to lift the torch up. Now I will have to tell the machine to wait a clearance delay. So I copy those lines. After waiting the clearance delay, I will call the M802. This will turn off the output number 3, so the torch stops lifting up. Right now, if I do like that, it won't work because there's some conflict with the macro pumps. Now I go back into the macro folder of the plasma profile, open macro pump. Here in this macro, just keep running in the background. The machine will check constantly if the move Z axis up key is pressed. If it is not, it will turn off the output number 3. And even if I try to turn on the output number 3 using the macro M801, this macro pump will still deactivate it. So I will have to tell this macro that the machine is running a G code. Don't do all of this. I will do that through a variable in Mach3 that can be read through all the macros. If get var 1000 inferior than 1, then do this, and I will add one more and if here. As you can see that I deactivate those two messages because they are annoying. I'm done with the macro pump. I will save it. Now I will modify the macro M801. I will tell it to set var 1000 to 2. So it's superior than 1. And here I will call set var 1000 0. Now I think that the torch will lift up after each cut, but I wanted to make sure that the variable 1000 will be set to 0 every time I click on reset. So I create a new macro. I just copy this one. I will name it M800. In here I will only leave the line set var 1000 0. Delete this line. Save it. Now I will open Mach3. Here in Mach3 you go to config, general config, type in M800 here and check this box and click OK. You can ignore this message. Now let me try to generate a G code in SheetCam for the 2 circles. I will import the drawing for the 2 circles. I will reduce this. I don't want to cut this fast. Let's say 5,000. Now I will click on post-processing, 2 circles, test clearance. Now let me open that file to see how it looks like. As you can see here, at the end of each cut, after the torch is turned off, M05, and the machine will pause 1 second, and then it will call the macro 801. This will activate the output number 3, and the machine will wait 2 seconds, and then it will call the macro 802 to turn off the output 3. The torch will stop lifting up, and then the machine will continue to the next cut, and this cycle repeat again here. I think that's it. Let's see how it works on the machine. Yes, it worked. As you can see here, the torch lift up about this high, probably about 15 millimeter. So if you want the torch to lift higher, you only need to increase the clearance delay in the post-processor. Now I have everything work exactly as I wanted. So the installation of this THC system on Mach3 is now a success. Now before letting you go, I just wanted to say a few words about this installation. I think that the THC system worked really well for its price. The installation of the system took me really long time because the manual wasn't easy to understand, and I also have to do everything from scratch to make this system comparable to Mach3. There's no instruction on that. Also, it took me so much time to debug the problem with the motor that the torque wasn't high enough, and also the speed was too low. If I didn't need to do all of that, like writing the macros, buying new motor, testing new motors, lead screws and everything, it probably will only take me a few hours to install this on and make it work. But actually I'm kind of glad that I made all the mistakes, so you don't need to spend time and money on choosing your motor and your lead screws. I will try to put together an installation guide that includes everything I did here, and also the diagram to connect between the THC and the Mach3 controller. It will also include all the macros and everything, so you can follow that guide and make this system work very quickly. Just look into the description of this video for the link to download my manual for this THC system.